Hello, welcome. Let's try to solve another Leetcode problem, 940, distinct subsequences 2. So for this problem, we are giving a string, and we're going to return the number of distinct non-empty subsequences of S, because the number can be really big, so we're going to use a modular, 10 to the power of 9 plus 7. So from here, we need to understand what is a subsequence. Basically, um, yeah, the subsequence is not like a subarray or something else. It is just subsequence. So for example, ACE is a subsequence instead of AEC for this string ABCDE. Yeah. Now we're gonna count how many of them, but there will be no duplicate. So for example, ABC in total it's gonna be 7. So how can we solve this problem easily? Actually, if we are seeing some problem like the total number of distinct like subsequences, if the final result is going to be 10 to the power of 9 plus 7, definitely this is going to be a dynamic programming problem. Yeah. Now we need to find some formula which we can count the total number of subsequences, but it is not so easy. So for example, if we have a character A, it is A. Next we're going to have a B, so this is A, B, and another B. Yeah. And next we're gonna have a character C, so we're gonna add C with all the distinct ones, so like AC, ABC, BC, and a unique character C. So if we are counting like this, it seems it's really difficult to count because sometimes there are gonna be duplicates. For example, there's a duplicate A here we have another 2 duplicate A's. But how can we solve this problem easily? So instead of counting it one by one with the current characters, because if we use this, maybe we need to solve how can we avoid the duplicate. How can we find it? Maybe you're going to think we can use a set. But as the total number is going to be really big, we cannot use a set. We have to use a better way to solve this problem. So instead of counting the total number of unique subsequences one by one, so we're gonna count all the subsequences which add with a character like A, B, C until Z. This is gonna make the problem really easy to solve. So from the beginning, we're gonna prepare a dynamic programming array. So the length of the array is gonna be 26. So inside it's gonna be 0. Now we're gonna check this character A. So if we are finding a character A, what are we gonna do? So according to our definition, so for each of the index, it's gonna be the character like A, B, C until Z. Yeah. Now we have a character A. What are we gonna do? We're gonna count the total sum of this F array. It's gonna be 0, and we need to plus 1. Because anyway, we're gonna add a character A to any of them, but currently we have nothing, so this means 0 plus 1, we have a character A, so from here, from index 0, we're gonna update it to 1. So from here, we're gonna update it to 1. Next, we find a character B. What are we gonna do? So for example, this is gonna be the next character. Yeah, we're gonna use the same formula. We're gonna calculate the sum of the F array. It's gonna be 1, and this is a character B. So 1 plus 1, it's gonna be 2. So for this is 0, we're gonna update it to 2. Yeah. Now what are we gonna do? We're gonna check the next character, which is C. So for this character, we're gonna still use the formula. Sum of the F is gonna be 3 plus 1. So at this place, it's gonna be 4. Yeah. So 1, it means the current character adding with the C. So for example, this is a C. This is a unique C. This is 1. And the previous 3, it means something like this. A, B, and B. The total sum is 3. We just need to use this 3 plus 1. So it is here. Yeah. So finally, we're going to calculate the total sum of F. It means the total number of all the subsequences which add with A, B, C until to Z. So the total sum of F is 7, and 7 is our answer. So this is why this is right. So now let's just use dynamic programming to solve the problem. So let me prepare the mod first, and I think I want to check the character one by one. So for C in S, let me define the F array first. It's gonna be 0 times 26 because there are 26 characters. Now we're gonna update the F array. It's gonna be all the character minus all the A. So for this value, for the current character, so for example, it is adding with A, we're gonna check how many of them. It's gonna be 1 plus sum of F. Yeah. So for this formula, maybe you think this is a string, at this position we have A, and here is B, C, D or something, but here we have another A. Yeah. So this A, so for example, we called some values. Yeah. Some numbers maybe, so for example, it is 12. Now we go to this A. What's gonna happen? What's gonna happen for this A? We still need to update the formula with 1 plus the sum of F instead of this value plus equal to 1 plus sum of F. Instead of that, this is wrong because, yeah. So currently for here, so for example, adding with this A, it is 12, and now we have another character A, B, C, D or something else, but now we are finding another character A. Yeah, even we have a duplicate, this is okay. We still need to count how many characters adding with A, adding with B, adding with C, and the total sum gonna plus a 1. So this unique A gonna be another one because others, so for example, it's gonna be AA or AAA, but we still need to count this one, it is A. So this is why the formula is equal to 1 plus the sum of F. So finally, we just need to return sum of F, and do not forget to use the modular. So here, we also need to use the modular because the final result is going to be really big. Now let me just run it and submit it to check if it works. Yeah, as you can see, it works and it's pretty fast, and the time complexity is 26 times the length of the string. So it is 2000 times 26. Thank you for watching. See you next time.